Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, we are going to discussing about the gender classification by names using machine learning. So let's see the demo first. So this is the demo applications built by using Python and Flux. So now what I can do, I'm simply going to give here one name. Let's call my full name. Let's call me Shudar Chando and try to predict it out. Now you can see it give me the output is male. Okay, that's mean the gender of this name is nothing but called male. Now let's click on here the back button and try to give here another name. Okay, so let's give here another name. Let's call Pooja. Okay, and try to predict it out. And you can see it's called female. So this is how the application is look like and how it is work. So without wasting your time, Har Har Mahadev बल के start करते हैं tutorial. In order to building the gender classification by names project, you're going to use the dataset from the Kaggle that's called the Indian and English names. And this is our dataset which having two columns, names and the gender. Now using this dataset, we are trying to building one machine learning model and try to predict the names of the gender. Is it male or female? For this project, I'm going to using here the Jupyter Notebook. You can also use here the Google Colab or PyCharm itself. And this is our Jupyter Notebook kernel. And you can see here dataset file. This is a file inside my same directory where my IP1 file is located. Now I'm going to click here and open this IP1 file that I created before. You can also click here new and also create here new Python file. So you can see here, this is our new Python file in an IP1 format. Now I'm going to import here some necessary library and try to load the dataset from my directory. So let's say first I'm going to import here the pandas, import pandas as pd. Then I'm going to import here the numpy as np. So pandas is necessary in order to load the dataset from my directory, and numpy is nothing but help us to do some multi-dimensional array calculations. Then I'm going to import here the job lib, import the job lib so that we can store our machine learning model in our directory so that we can use it later on. Then I'm going to importing here the train test split. Before building any machine learning model, we need to also divide our data set into train, test, and split. I mean 80% for the train data and 20% for the testing. So from sklearn dot model selections, you can also use the tab key from your keyboard. So it will give you the auto suggestions on your Jupyter notebook. Okay. So I'm going to using here the model selections and I'm going to import here the train test split. So first time it will take time. So it will automatically importing this module. Okay. So you can see here train test and split. Then I'm going to import it from sklearn dot feature extraction. So feature extractions. So from the feature extraction dot text, I'm going to import here the count vectorizer. Okay, because this is one textual data, and also this is nothing but one NLP types of text. That's why I'm going to using here this sklearn dot feature extraction dot text, and I'm going to importing here the count vectorizer. Then I'm also importing here another things that's called sklearn dot feature extractions, and I'm going to importing here the dictionary vectorizer. It's also called the dict vectorizers. So it is helpful how you try to vectorize your data in the form of dictionary. So shift enter and it will load all the module in my kernel. Fine. Now I'm going to import here the dataset from a directory. So let's say pd dot read underscore csv, and I'm going to passing here my dataset name. Let's call the names and underscore dataset dot csv. Okay. Now let's assign it to the variable that's called the df. Okay, df. So this is our data set. Now if I try to check this data set, let's call df.head, and you can see here this is our data set that you see earlier in the Kaggle in the name and the gender, it having two columns. Okay, you can also check the size of your data set. Let's say df.size. So you can see here how many columns are available, no, how many rows are available, because it having two columns and it having 225,462 rows. That means this kind of data are available inside my data set. You can also checking this way df.columns in order to getting all the columns name. Okay, you can see your names and gender. This is how you can checking your column names. Let's say it having multiple number of columns, so it's sometimes it's not actually show in your Jupyter notebook. So you can using these things df.column in order to checking all the column name. But in my case, it just having the two columns. Simple. Okay. Now you can also checking the data types of the each column. So you can using here df.dtypes. Okay. So in order to checking the data types of the each column. So you can see here name is object, it's mean a string data type. and gender is nothing but an object. So both of the things are nothing but objects. So now let's checking for the missing value. Is there any missing value are available? Let's say checking for missing value. Okay, so I can using here df dot is null and dot, let's say, is null, because this is a textual data, and I'm simply going to sum it out. Okay, now you can see here it having names is 0 and gender is 0. That means it don't have any missing value. Okay, fine. Now let's checking for the numbers of female name and also number of male name. Just have a look about the data, that how our data looks like. So what I can do, let's say number of female names. Okay, so how can I check that? Let's say df, and if I go inside this data set, you can see f means female and m means male. It's under inside the gender column. So what I can do, I go inside this data frame, and now from the data frame, I'm going to extract the gender. If the gender is equal to female, then I'm going to checking the size of them. Now you can see it having the 15,000 of 15. Okay, is nothing but 1942. That's mean it having 1 2 3 4 okay, 1 lakhs. Okay, 1 lakhs 51,942. Quite big number, now we can also checking this one in a way of for the male, okay, male names. So I need to convert them into the m. Now you can see it having the 98,520 numbers of names are male. That's mean most of the names are available inside my dataset is female. Okay, well, fine. So now what I can do, I'm going to take in this dataset in another folder, so that because we're going to do some operation on our dataset, so that our original dataset is not converted or it's not changes. So that's why I'm simply going to copy our dataset in another variable that's called the df underscore names, so that our original dataset is not changes. Okay, this is our original dataset. So we're going to change something here. We're going to change this female to the 0 and male to the 0. That's called the categorical encoding. I need you to convert your categorical data into the numerical data. So that's why I'm simply going to reserve our dataset in a new folder, new variable that's called df underscore names. Now inside this df underscore names, I'm going to converting this gender, okay, female to be 0 and male to be 1. Just going to converting this categorical feature into the numerical features. So I'm simply going to using the replace, and inside this replace functions, I'm going to giving here one dictionary. So if it is female, then I'm simply going to make it 0. If it is male, then I'm simply going to make it 1. Okay, and after that, I'm also giving here input equal to true, so that it can change inside this our data set. It can change this whole thing in our data set. Okay, that's called true. Okay, now df underscore names, if I checking this df underscore names and dot head, so you can see now it's the gender is converted into 0 and 1. If I checking this just df, it not changes. Okay, it not changes. So let's say df underscore names. Okay, that's it, fine. Now it is replacing all the female value with the 0 and male value with the 1. So you can also giving here comment. So let's say replacing okay, replacing all female, okay, to 0 and m to 1. That's it. Okay, replacing all f to 0 and m to 1. That's the replacing thing that is happening here. Now if I try to checking this unique number of value, is there any null value available? If there is null value available, it will actually give me some kind of error. So you need to also checking that is the all of the female and the male is converted to a 0 and 1. So what I can do, you can simply going to using here df underscore names and dot gender dot you can using here the unique. Okay, unique. You can also do this thing in another way also. You can see here 0 and 1. That's mean you don't have any null value or no missing value available or any mismatch. Okay, so you can also using this thing in a way. So df underscore names, you can also using this way in this format. So let's say gender, and you can also checking this way unique. In this way you can also checking that the same result. But in the upcoming, I mean the latest pointers, you can also using this column name using dot. Okay, you can also using this formula too in order to checking all the value. In this case also, you can also do that. Okay, fine. Now what I can do, we can also checking these types of these df names. So if we try to check in these data types, so you can see here name is objects and gender is converted to integers. So now what I can do, we need to convert our data set into x and y. It's called the dependent and the independent features. And also you can see here this is a name, because this is one name, and this is also in a form of category. We need to convert them into the numerical format. So what I can do, we can simply using here the count vectorizer. We can simply convert our data into the some kind of vectors. Okay, some kind of vectors. So what I can do, we simply going to take some shells. Let's take some shell, shift enter, and we're going to using here the count vector in order to get in the features from our name column. So what I can do, we can simply check the, let's say, f features. It's called the x features. It's called the dependent features. So x feature is nothing but df underscore names, and I'm going to taking the name. Okay, this is my x features. So now I'm going to convert this x feature into the count vector. I'm going to passing this data inside the count vector in order to get in the features. In order to get in the features. So what I can do, we can simply using here cb equal to count vector, just getting here an instance of the count vectorizers. And after that, I'm going to using here the cb dot fit transform. We need to fit and also transform our data. So that's why we're going to using here the transform, fit transform. But when you try to do it in the y variables, you need to using here just transform. Now what I can do, inside this parameter, we're going to using here this x features, this x features. Okay, x should be the capital. Okay, thoda x features, and we're going to getting the values of the x features, and we're going to simply convert them into the s type equal to utf8. So you can pass here u. So now the whole data of the names is converted into the vectors, So let's uh, store it inside the variable. Let's call the x. Okay, x. So now it's our data, the x. If I try to check in this x, so this is nothing but one sparse matrix. You can see a sparse matrix. This is nothing but one sparse matrix. That's when our data is converted into the sparse matrix. Okay, so you can also check in the shape of that. Let's try to check the shape. Okay, it's the shape of our data set. The shape of our data set. Now what I can do is simply going to save our vectorizers so that you can also use this later on. So okay, so let's say in this types, if I using my PC or desktop, let's say electricity gone. Electricity is gone. So what I can do, you can simply going to store your vectorizers in vectorizer in a form of joblib or in a form of the pickle format, so that you can also use this later on. You can use it later on. So you don't need to use your data set or do this thing again and again. So what I can do, I simply going to save our vectorizer inside one pickle format. So what I can do, we can using here this, let's open, and let's say using here the gender vectorizers, so that we don't need to using it later on. Okay, dot pickle format. Okay, or you can also share it with your friends. Okay, so that it can further explore this one, so that you don't need to pass here this data set. With your data set, you can also using this vectorizer format. Okay, so now what I can do, you can also using here, let's say gender vectorizers. Okay, it's the optional part. You can also do it, or otherwise you don't need to do it. Okay, so joblib dot dump, and inside that I'm going to passing here my cb and my gender vectorizers. Okay, so now you can see here this is our data. Now it will store it inside a pickle format. So I am simply going to close it. Okay, gender vectorizer and dot close. Okay, simple. Now if I go inside my folder, okay, just where idhar pe jana hai. Okay, now you can see here gender vectorizer pickle file is generated. It's nothing but 1.35 MB. Cool. So now what I can do, we can simply go into now getting all the features. So let's say cb dot get features name out. So it will giving you all of the features. Like you can see ABN, BBHA, and some Indian names also, and some English names. Because this is our data set, it having the Indian name and also the English name. So you can see here, this is our data set. We also having our vectorizers, and we also convert our data into the count vectorizers. So now what I can do is simply going to divide our data set into 20 split. So for that, we're also checking the y. So let's say df underscore names. and dot gender. Okay, so to give me the y. Okay, so our x is ready. X is nothing but our name, and y is nothing but our genders. That's been using the name, we're to predicting the genders. So now what I can do is simply going to using here the x train and y train. Okay, and x test and the y test, and passing it inside the train test split. So let's using here the train test split and passing here x and y. Then let's giving here the test size, also giving here 0.2, then random state. Okay, let's giving here 42 so that it not changes again and again when I try to run this shell in a multiple times. So let's say x train, and then we have the x test, and we have the y train, then we have the y test. Simple. Okay, now we divide our data set in the train test split. Now what I can do is simply going to using some machine learning algorithms. Okay, so let's try to first implement here the naive Bayes classifier, because this is one classification task. So let's say from sklearn dot naive Bayes. So I'm simply going to using here the multinomial NB. So this is nothing but the naive Bayes classifier. So let's say CLF, okay, equal to multinomial NB, and I'm going to using here CLF dot fit our train data. So let's say X train, and we having the Y train, okay, Y train, and simply I'm going to also classify the score of that. So a score based on my X test and also Y test. That's it. So we got here 71% accuracy on our testing data. This is our score, and we feed on our training data, and on our testing data we get here 71% accuracy. Okay, so you can also print it out. Let's say printing, let's say accuracy of model. You can also using here the format specifier. So just passing here the CLF dot score, and I'm going to using here okay, not like that. I need to using here the score like this way. Okay, and using here the format, and inside this format I'm going to passing here CLF dot score, and I'm going to using here the X test and Y test, and I'm simply going to multiply with 100. Okay, that's it. Okay, and it is percentage. Okay, now you can see according to the model is 71.00, this kind of percentage I got. Okay, fine. Now this is our accuracy of the model, and we can, if I checking this accuracy for the testing data, so training data, so we can simply going to copy this out, and I'm going to pasting it here, and we can got the accuracy for our training data, and we got here 99% accuracy. Okay, which one good. So now let's try to do some predictions. Okay, let's try to do some predictions. Okay, prediction using our models. Prediction, थोड़ा prediction करते हैं इसको. Shift enter. Okay, now let's taking one sample name. So let's sample name. Okay, let's take one sample name. Let's take my name. Okay, Chandu. Fine. So what I can do first, I need to convert them into the vector, so that I'm going to using a CB dot transform. Okay, transform. So why we need the CB that you can see here, so that you can use it later on, this CB, I mean this count vectorizers, and it is stored inside this gender vectorizers, because it having all the vectors, so that you can use it later on when you try to test it out. Now inside this transform, I'm going to passing my sample data, my sample name, and let's try to make it sample names. Okay, sample names, so that it looks convenient. Sample names, and now I'm going to convert them into the two array, so that it can give me one array. Now let's try to make it vector, and now I'm going to pass this vector inside my classifier. So that's a CLF dot predict, and I'm going to pass in here my vector. So it will give me one means the male name. Okay, one name is male name. Okay, so Chandu is male name. Fine. So let's taking here another name. Let's call Shuchitra. Okay, so let's take it down. Yeah, 0. It's called the female name. Quite good. So now our name Bayes algorithm is actually working very fine. So let's try to check some another names also. So let's try to checking sample names 2, Sample names 2. Let's giving here one Russian name. Let's call Natasha. Natasha. Okay. 0. Russian name. Also working fine. Let's try to okay, let's try to giving here some random names. Okay, let's say sample let's say 3. Sample let's go name 3. Let's taking some random names here. Okay, let's get Chando. Let's say Shuchitra. Let's say take some name. Let's say Nasha. Let's say Pooja. Okay, Pooja, it's okay. Okay, let's say Kabir Singh. Kabir. Okay, then taking another name. Let's say Joseph. Okay, Joseph, fine. Joseph. Okay, fine. Let's take the Dhoni name. Dhoni. Hey, थोड़ा कीबोर्ड में प्रॉब्लम हो रहे हैं. DHONA. Okay, Dhoni. Okay, fine. So now what I can do, I am simply going to pass in this name inside my vectorizers. So simply going to copy this out, vector, and I'm going to pass it here. And this is sample name 3, and this is a classifier. Okay, you can see 1 is male, and 0 female, Nasha female, Pooja female, Kabir okay male, Joseph one okay, Dhoni okay. Let's make it Mahi. Female बोल रही है यहाँ पर. Okay, let's take it. Okay, Virat. Okay, Virat Kohli. Okay, it's now 1. Fine. Okay, so now what I can do, we try to creating here functions. So which can give me the just taking one name and give me the is it male or female, this kind of things it will give. But you can see just it having give me some numbers, so it's not convenient. So let's say making one gender predictor. Predictor. Okay, predictor, and it will take one name. So let's say name. And now what I can do, we're simply going to using here convert them into the vectorial. So let's say test name, and this is our name. So it's inside one list, and I'm going to passing is inside my vectorizer. So let's say transform, and inside this transform, I'm going to passing here my test name, and then simply going to convert them into 2 array. Okay, these are our vectorizers. So let's call vector. Okay, so if the vector of the classifier, if the classifier predict the vector is equal to 0, that's mean it is nothing but one female name. So let's try to return here female, otherwise it should be the male. Okay, return the male. Fine. So these are our functions. So now let's try to copy this out, and I'm going to using here a name. Let's say Mishu. I don't know. It's called female. I know Mishu name is female. Okay, let's try to using here another name. Let's say Jamie. It's also the okay. It's a male name. Okay, I know the Jamie is nothing but on female name, but yeah, my brother name is Jamie Kerr, so it's he was also male. Okay, so it's also working fine. So now what I can do, we can also creating here one thing and taking the name list and try to pass it inside this gender predictor. We can simply copy this out sample names, and what I can do, we can simply iterate to all the value from here. Let's say for I in the sample names and try to print it out. Okay, let's try to print here the I, and we can simply take in this way, and we're going to passing here this inside the gender predictor, and I are going to passing here the I. Now let's see. Chando male, Shuchitra female, Nasha female, Pooja female, Kabir male, Joseph male, Virat male. Okay, it's also working very fine. Okay, so now what I can do is simply going to using this one and try to building also one machine learning model using this name bias classifier. Also, you can also do some feature analysis on the custom functions. So let's try to also extract it. Okay, because this is the Thodi. You can do it as a beginners of a machine learning engineer. You can also do it out. But let's try to explore it more. Okay, let's try to explore it more so that you can also use it inside your research paper. Otherwise, your thesis or defense. So let's try to do the custom feature extraction. So custom feature extraction. abstractions. Okay, so it's called feature analysis, not called the feature extraction, feature custom feature analysis. Okay, so by analogy, the most of the female names are end with a or I. Okay, and with a or I, or have the sound of a. That's mean you can see Suchitra, it's having the, Nasha having a, Pooja having a. Okay, but male name don't have. Male name should be the U or the R or the H or T. But most of the female name it ends with the a or the I or the sound of a or sound of a. That's mean by analogy, most female, okay, female names ends in a or I, okay, or has the sound of a. We know that by analogy. So what I can do, we can simply creating here on functions and try to taking the first one letter, then two letter and three letter, and try to checking that is it the sound of the female or sound of the male. But male don't have any sound, but female having the sound. Suchitra, Nasha, okay, having the sound of a at the last, at the end. So what I can do, we can simply creating here on functions and try to also using this analogy and try to building one predictive model. So what I can do is simply going to define on functions. That's called def. That's called features. Okay, features, and you're taking one name. And what I can do, we can simply going to convert this name into the string. So let's try to convert them name into the string. And after that, we simply going to make it lower letter so that you can see Chandu, it's also converted into lower letter. Okay, so what I can do, we can simply going to convert them into lower letters. That's called name dot lower. Okay, and after that we simply going to return here on dictionary. So you can see here why actually return here dictionary. If you see earlier, you can see here we also import here the dict vectorizers. The dict vectorizers actually help us to do these things, do the vectorizer from in terms of dictionary. Okay, so that's why you need to passing here one dictionary. We need to passing here one dictionary. So what I can do, we can simply getting the first one letter, then two letter and three letter, and last first letter, first two letter, and the first three letter in the form of dictionary. So let's see what I'm talking about. Let's say this is what called the first letter. Okay, first letter. Okay, first letter of a name. Okay, so let's call names. Okay, for my name, so it's the first letter, now what I can do, we're going to checking the first two letter and first three letter. So it's called the first two letter, and it's called the first three letter. So it's coming for 0 to 2, and it's called 0 to 3. I'm simply going to creating here on dictionary so that we can get in the features. So now we're going to taking this last letter. So let's say call the last letter. Okay, last letter. So what I can do, we simply going to reverse it. So name into -1, -2, -3 like that. So copy this out and I'm going to paste it here and paste it here. So last two letter, last three letter, and it's called 2 to all of the rest of them and 3 to rest of them. Simple. Now it is giving me all of the letter in the from a dictionary. So if I try to checking this out, let's try to call in these functions so that you can see it clearly. Okay, last two letter, last three letter. Okay, now let's say if I try to convert them into the vectors. So what I can do first, I need to using this np dot vectorizers because I need to convert them into vector. So let's say vectorize. Okay, vectorize, and inside that I'm going to using here my features, just calling this function that's called the features, and this is our feature vector features. Okay, you need to do this way, now what I can do, I am going to call in these features. Okay, it's called the features. Okay, let's make it features. Okay, let's make it features and also features. Okay, fine. Now what I can do, I am simply going to passing the data inside my features. So features, and inside this features, let's say passing the data in the form of list. So what I can do, I'm simply going to copy this out. Okay, and I'm going to paste it here. Okay, paste it here. Now if I shift enter, now you can see here it having an array, having the first letter you can see C, first letter two letter is CS, first three letter is nothing but cha, last letter is nothing but U, last two letter is nothing but DU, last three letters is NDU. Okay, this is how our data set is look like. So what it can do, it can just checking all the value for the first letter, first two letter, first three letter, and last two letter, last three letter, and also last letter, and try to creating here on vector. Try to creating here on vector. This is the custom feature analysis. Custom feature analysis for the analogy of the data. So now what you can do is simply going to converting this whole data set into in the form of the vectorizer, in the form of the vectorizer, this kind of way in the features vectors. So what I can do is simply going to call in this one, this features, and we're going to passing all my data from my names. So from the names, what I can do, I'm going to passing all of my names. Now our all the data is converted into the this kind of analogy, okay. So what I can do is simply going to make it, let's say df underscore x, and this is my features. So now let's try to do the same thing for dfy. So df underscore y, okay, equal to df names, and after that I'm going to passing here my gender. Okay, fine. So now what I can do, we simply going to using here the dict vectorizer that you import it earlier. So what I can do, first I'm going to simply going to creating here on corpus and try to feed it out that is really working or not. So what I can do, I'm simply going to creating here one corpus. But before that, let's try to also input it here. Let's try to in creating here one instance of the dict vectorizer. So what I can do, we can using here, let's say db, okay, db equal to dict vectorizer. Okay, we're just getting here one instance of that. And what I can do, we can simply going to creating here one corpus. So what I can do is simply going to creating here one corpus. Okay, corpus, and we're giving here two names for the male and also one name for the females. So we're going to using here the features, these features. So what I can do is simply going to giving here two names for the male and the female. So let's give here the Arab. Okay, you also giving here my name. Okay, and let's giving here another name called, okay, Julia, Romeo Juliet. So let's make it Julia. Okay, fine, the male name and the female name. Okay, fine. Now this our corpus is ready, and also dict vectorizers. So what I can do is simply going to pass it inside my dict vectorizer, and I'm just try to checking this out, it's really working or not. And corpus, and after that it also transform the data set. Okay, it is db dot transform. Okay, transform, and inside that I'm going to passing here my corpus, and this is about transform data. So let's go transformed. Okay, transform data, and if I try to printing this transform later on, so transform, so you can see, just to wait, this is an sparse matrix. Okay, sparse matrix. If I try to printing it out, let's try to print it out, if there anything happen. Okay, now you can see sparse matrices look like. So 0 to 0 is nothing but 1. Okay, and 0 to 2 is nothing but 1, 0 to 4 is nothing but 1, 0 to 7 is nothing but 1. It is nothing but the index of the data in the form of dictionary, this kind of dictionary, because this is one textual data, it just converting this data into the textual format. Okay, this is the similarity. So now what I can do, we can simply go into getting all the features name. So for that I'm going to using here db dot features names, I mean get features names. So db dot get features name, so get features names out, and you can see here first letter is C, then last letter J, and you can see CH, first letter, okay, first letter of the J is nothing but for the Julia, then Jayu, then you can see Cha, then Jul. That's means it's nothing but creating here on in terms of dictionary, and this is one sparse matrix. So just taking this out for the sample data. Now we can simply go into using it on our whole data set. So what I can do, we can simply going to convert our data set in the train test speed, and I'm going to passing here my df of the x and df of the y, because it is already converted, already converted inside our features vector. Just to check that how our dict, I mean how our dict vector actually work. Now we simply going to using this formularity in the whole data set. So our whole data set is available inside this dfx and dfy. We already converted them into dependent and independent features. So what I can do, we can using here the df. Okay, let's say df. Okay, df xtrain. Okay, df xtrain. Okay, x train. Okay, then okay, let's try to convert them x into the capital so that it looks convenient. Then what I can do, we can using a df x test, then df y train. Okay, then we have the df y test like this one. Okay, fine. Now what I can do is simply going to pass it inside my train test split, and I'm going to giving here my df df dfx and dfy. Okay, dfx, and we have the dfy. Okay, this is the underscore x. That's it, that's it. Now what I can do is simply going to passing here my test size. So let's giving here the test size. Okay, test size is nothing but 0.2. Then we having the random state. Okay, that's 42. Well, so our data set is converted in the train test split for our analogy. So if I try to check in this dfx train, and now you can check that the first letter of the t, and it will convert in this all the data in the form of the train test split, and try to also convert them into the from the dictionary. So now what I can do, we can simply go into using here the DC vectorizer and try to transform our data set. So what I can do, I simply going to copy this out. This thing, I don't think the corpus is needed. Corpus is nothing but my dfx train. So what I can do, we simply using here the feed transforms. So I simply going to remove this, also remove this, and I am simply going to using here the feed transform because it also feed the data and also transform the data. Okay, feed transforms, and now I'm going to passing here my df x underscore train. So pass it and shift enter. Now it will convert our data into the in the form of the sparse matrix. You can also see this sparse matrix in the form of this this way. Okay, so now what I can do is simply going to creating here on a decision tree classifier and try to feed with the machine learning models. Okay, well, so we back again. Now what I can do is simply going to apply here the machine learning algorithms. So for that, we're simply going to using here the decision tree classifier. So I'm going to import it here from sklearn. Let's say from sklearn dot tree. I'm going to importing here the decision tree classifier. Okay, decision tree classifier. So this is the classifier. I'm going to using it here because this is an classification types of problems. So now I'm going to creating here the classifier instance. So let's say DCLF, and I'm going to make it called decision tree classifier, and after that I'm going to fit with using my decision tree classifier. But before that, I need to also transform a data set into the dict vectorizers. So that I'm going to using db dot transform. So transform, and inside this transform, so what I can do, I'm simply going to passing here my df x underscore train. Okay, this training data, and then I'm going to store it inside a variable that's called the my x feature. Okay, let's say x features. Okay, features. Okay, now I'm simply going to pass it inside my dclf. Okay, dclf dot feed, and I'm going to passing here my x features. So this is my x features, and after that I'm going to passing here my training data. So dfy training data. Okay, this is my training data also. Now what I can do, I am simply going to run it out, and after that I can got here some scores, and later on we try to test it out. So shift enter, and now you can see here it will try to fit with our data and try to test from it and try to feed the data, and after that you can also get the score using this formula. Let's call here is it. Yep, here is it. You can using here CLF score. Otherwise, you can also using a DCLF score. Okay, that's fine. Now you can see it also loaded, and it will take few minutes in order to load our data because this is a whole data set, and it will convert our data set into the from the dictionary and also try to apply here the decision tree classifier. Okay, now you can see it executed this decision tree classifier. So now what I can do, I am simply going to test it out that how it is really work. So what I can do, I'm simply going to creating here on sample names. Let's call sample underscore name. That's example. Okay, and let's give here one name. Let's call Bandhan. Okay, Bandhan, Raksha Bandhan. Okay, then what I can do, I'm simply going to using here db dot transform because I need to also transform our data, and we're going to transform our data in terms of features. because we have the features that you can see earlier. This feature we actually created, and now inside this features, I'm going to pass in here my sample name. Okay, my sample names, and inside that I'm going to made in here transform df. So transform, okay, let's make it transform df. That's it. Okay, df or db, that's a db. Okay, did our data. Now what I can do, I am simply going to using this transform db to the array. So you can also use it like this way to array. Now it converted to the array. Now what I can do is simply going to pass it um, inside my classifier. So what I can do, dclf dot predict, and I'm going to pass in here predict, predict, and I'm going to simply pass it here my transform db. Okay, this one. Now you can see array 1. Array 1 is nothing but the name of the male. So let's give here another male. Let's say Pooja. So you can see her 0. It's the name of the female. That's mean it is really working very fine. That's mean if it is nothing but the 0, that's mean the female. If it is 1, that's mean this is a male. Now let's try to do the one predictions again. So let's say name, let's say example number 1. So let's take another name. Let's call um, new name. Let's give here Chayuma. Okay, Chayuma. It's nothing but Nigerian name. Chayuma, Kayuma. Okay. So what I can do, I am simply going to do the same thing, this transform GB, and I'm going to copy this out. The same thing, this name example, and I'm going to pass it here. And after that, it will give me one result. So this call, let's say vector, result vector. Let's backed. Okay, let's make it underscore 1. Okay, so now what I can do is simply going to creating here dclf dot predict. If it is nothing but passing here the background underscore 1, if it is nothing but equal to 0, that's mean this is nothing but one female. So we're simply going to print it out. Let's say female. And otherwise what I can do is simply going to make it let's say else, and I'm simply going to print it out. Okay, print it out. Let's say called male. Okay, so it's a okay, it having some problem. Accept a 2D array but 1D array instance. So what I can do, we need to also pass this data, okay, example ones to array, and we pass here our data. But what's the problem? Example one, reshape it data is -1 to minus if the data has a single features or array, or reshape it. Okay, what's the problem here? If I try to check this out, you can see it's really working very fine. But what the problem is here? Okay, transform db. Okay, let's make it transform db1. Let's say transform underscore db1. Okay, again having some error. Okay, let's try to copy this out. The same thing. dclf.predict, and I'm going to pass it here. And after that, I'm going to make it let's say backed underscore 1. That's it. Okay, having the same error. Okay, let's try to check this out. What kind of error did I actually got? Well, the problem is happening because we actually passing the same data again and again. That's why it's giving me some reshape error. Okay, let's try to uncomment this one again, this Kayoma. And if it is vector one, I mean this one, equal to 0, that's mean this is a female or male. That's why we got this kind of error. Now you can see we got here the female. Okay, I actually passing his data in the same time again and again, so that's why I got this error. That's fine. Now it's really working very fine. So what I can do, we can simply going to save this model. So first I'm going to save this decision tree model in my folder directory. So what I can do, I simply going to using here open, and let's say this is called decision tree dot pickle file. And after that I'm going to using here the wb. Okay, fine. Then we can simply go into using it, let's say decision decision underscore tree. That's it. Okay, now this is our decision tree classifier. So what I can do is simply going to save it called joblib.dump, and inside is dump I'm going to passing here dclf and my decision tree. Okay, that's it. Now it is save it inside my directory. If I check this out just to avoid, you can see this called the decision tree.pickle file. Okay, that's really very fine. Okay, fine. Now what I can do is simply going to also saving here our name bias classifier, so that you can also use it later on. So you can using here another way also, that's called the pickle format. You can also using here the pickle format in order to dump it. Okay, so let's try to also do this out so that you can also know that what is about the pickle. So what I can do, I'm simply going to using the same thing. Let's call open, and let's keeping here another name. So let's call name detector model. So name detector underscore model dot pickle file. Then what I can do is simply going to convert into write mode, and after that let's giving here another name called decision tree underscore hey underscore 01. That's it. Now we're simply going to dump it out inside my pickle. So let's call pickle the dump, and after that I'm going to simply passing his DCLF, then our decision tree model 01. The same way you can also do this way. Okay, then after that I'm simply going to make it, let's call decision tree tree 01 dot, after that you can simply close it. Okay, okay, that's it. It also stored inside my same variable in the same folder. You can see here name detector pickle file, and the file length, the size of the file size is nothing but 1.9 MB, and it is also 1.9 MB. Cool. So now what I can do, you also going to saving here our naive bias model because we don't save it yet. So we're simply going to copy this out. Copy this out, and we're simply going to pass it out here, or using this jobly way. So what I can do, you can also using this pickle format, or you can using here the jobly way. This is jobly way. So simply going to copy this out, and I'm going to making this should be naive bias. Okay, naive bias. Then after that, I'm simply going to make it, let's call naive. Okay, naive bias dot pickle file. Okay, fine. Now after that, I'm going to using it jobly dot dump, and after that I'm going to using here CLF, my classifier name, then our naive bias. Okay, this naive bias. Okay, okay, that should be BAYES naive bias. That's fine. Now I'm simply going to close this naive bias. Okay, that's naive bias naive. Okay, simply going to close this naive bias, and it will store it inside one folder. Okay, syntax problem thoda double ho gaya. Okay, now if I try to checking this out, वीडियो काफ़ी भी लंबा भी हो गया है. Okay, now you can see neighbors.pickle file 3.26 MB. Quite good. Now what I can do is simply going to using this neighbors pickle file and try to creating here on Flux application. Yes, you can also using here this decision tree.pickle file. Otherwise also you can using this name underscore detector.model file and try to creating here the Flux model. So I'm going to show you that how can you creating this Flux application using this name bias, and your homework is to creating the same way using this name detector.model. Okay, maybe there should be some changes because you need to passing here inside the features sector, just creating his the feature from, and try to pass it here. It's your homework. It's your homework. So now what I can do is simply going to creating here the Flux application that you see earlier in the demo. So now we're going to see that how can I creating the Flux application for the gender classification by names. So this is the code for that, a simple code. Okay, now you can see here in this folder, you can see it having app.py, and also you can see here our Jupyter notebook file. It's called gender classification by names. You can also get the code from here, and all the code you can get it in my GitHub directory. You can simply go on here and try to download it and try to test it out here. Okay, so now you can see here in the app.py, actually simply going to creating here all the code using Pythons, and I just simply going to creating here one API and try to test it out. So now what I can do is simply going to creating here a folder that's called a static, and inside the static folder it have another folder that's called the CSS, and it having all the CSS file. Now inside this template folder it having two files that's called index.html, and another file that's called the result.html. So in index.html it having my style sheet and where the style sheet is coming from, and we having one container, and inside this container just having the gender classifier and gender classify gender using machine learning, this kind of message. Then inside this box is this container, it having one form, and inside this form it actually coming from the predict button. If I go into this app.py, you can see here it having one route that's called the predict. Okay, it is coming from here. Then it having one from code, and inside this from code it having one name, and name is nothing but called a name entry and simple one button. So when user give here one name, and after that it will try to actually clicking the submit button, and it will try to giving here the prediction that is the name is the male name or a female name, and simply it will redirect it to the space inside this result.html. So if the base value is nothing but call 0, it's mean it's a female, otherwise it will give me the male. That's it, simple. So this is the code for the result.html and index.html. Now this is the code for app.py. How it will look like. So first actually import here the Flux bootstrap, because we're simply going to using here some bootstrap types of frameworks. So that's why actually using here this bootstrap. If you see here index.html, you can see also extending here the bootstrap and underscore base.html. This is the new way the called the Flux bootstrap to actually creating your application more generic. So that's why using here this bootstrap. Now after that we import here Flux. From Flux we import in the Flux and the request and also the render template, because we need to render the template from our templates folder. Then we import here the NumPy, then pandas, the job lib, and also the feature extraction. Yes, you can also using these gender vectorizer here, but we can also using it here the count vectorizers if you wanted to do it out. Okay, that's the way you can actually do it. Okay, so first what you can do is simply going to creating here one initial route for our index.html, the simple index.html. Then what we having one button that's called the predict. If I go inside this index.html, and the button, this type is submit, and this is one predict button. And this when you clicking the submit button, when you're clicking the submit button, it will the action of the form is nothing but called predict. The action of the form is nothing but one predict. That's mean in a one form it having just one button. It's just having one button. It's called a submit button. So when the user is clicking the submit button, it will go to this predict. It will go to the predict URL or predict route. So what I can do is it's go inside this app.py and try to checking for the predict. Now it's also checking for which kind of method. Is a get method or a post method? Obviously it is a post method, because you try to put the data in our databases. That means it's a post method. If I try to fetch the data from our databases or the ML model, that's mean get method. I mean we try to post it out, and we need to also initialize here a method that's called a post method. Then we're simply going to read our data set and try to creating here dependent and independent features. And after that we're simply going to make this type should be UTF-8. Then simply going to using here the count vector, then try to fit it out in our corpus. Then we load our machine learning model that you trained earlier using NaPBias, and you can see NaPBias.pickle file. We're simply going to load it out. That's called open, and try to giving here RB, admin read mode. Then we're simply going to load it using job lib that we do earlier in our gender classification by names Jupyter notebook. Okay, here is it. Now what I can do after that, we're going to check in this if the method is post method. That's when we try to take the value from our name query. If I go inside this index.html, now you can see here inside this name, it having a name query. Now it will getting this value from the name query, and try to pass it inside a list and try to transform it using our gender vectorizer. These vectorizers. Okay, we try to actually do it in a same app.py. You can also load this gender vectorizer.pickle and try to do it manually. Okay, now what I can do is simply going to transform our data, and after that is simply going to classify them, and we're going to passing this my prediction inside my route. Okay, prediction is equal to my predictions, and name is nothing but my name query.upper. I'm simply going to convert them in the uppercase letter that you see in our demo video. That's the applications. That's the application. Simple. Index.html is just having extend bootstrap.base.html, and it having also super columns. And for the styling, because you actually using here the bootstrap styling, then we have one form, and inside this form we're simply going to calling here our predict a route, and inside that we having one input for name and one button. Simple design, simple design. Okay, so now what I can do, I'm simply going to run it out. Just going to click on here, and it will running this application on my local server. You can also try to implement it in AWS, or you can also put it inside the OnRender, which one is also on free hosting application. You can also development your machine learning model on here. So now what I can do, I'm simply going to click here to follow link. Okay, follow link. So our application is loaded. Let's call the gender classifier and classify gender using machine learning. If I go inside my code and try to check the index.html, now you can see here inside this container, it's just a container. It having the gender classifier and classify gender by using machine learning. And this is also a container. If I see here, just to see, this is also a container, and inside this container is just having one input text and also one button. Simple. So let's giving here a name. Let's call Chando. Okay, my name, and click here to predict. Now you can see just a white because it is loading the data. You can see male. Simple. If I click to back, You can see, you can also enter here another name. Let's give here my full name, Mishuda Chandu, and try to predict it out. Now you can see just a white, you can see male. How quickly it will give me the response. Okay, let's try to giving here another name. Let's give Pooja. Okay. Okay. You can see female. How quickly it will give me the response. Back again. Let's give here another name. Let's call Shuchitra. Let's give you the full name. I don't know. It will give me the correct output or not. Let's give me the correct output. Female. That's really fine. So that's about from my side. And how can I building on gender classifications by names using machine learning. Hope you enjoyed this video and make sure to subscribe to the channels and don't forget to hit the bell icon. And I'll be back with another tutorial. So till then, take care and bye bye.